Assalamualaikum and hello everyone. We'll be presenting our site with the title of Techniques of Differentiation.
Pause with the fans. Pause with the pause with the pause with the fans. Pause with the fans.
Before that, we would like to introduce ourselves. My name is Rashami Ramita Rasman. So, what is differentiation? Differentiation measures the instantaneous rate of change of a function with respect to its variable, often represented as the slope of the tangent line to the curve at a point. Now, let's move on to the techniques of differentiation. The first one is power rule. It is used when the function is a power of x. The second one is constant rule. It is used when the function is just a number. The third one is constant multiple rule. It is used when a constant multiplies a function. The fourth one is sum and difference rule. It is used when terms are added or subtracted. The fifth one is product rule. It is used when two functions are multiplied. The sixth one is quotient rule. It is used when one function is divided by another. The seventh one is chain rule. It is used when one function is inside another function. Last but not least is trigonometric function. It is used when the function has trigonometric terms.
Assalamualaikum, my name is Nur Arisana Jihad. So I will explain to you about question 2. Part A. The function is y equals x cubed times e to the power of tangent of 2x. Since it is a product of expression, we use the product rule. First, differentiate x cubed, the result is 3x squared. Next, differentiate e to the power of tangent of 2x. We use the chain rule. The derivative of tangent of 2x is 2 times secant square of 2x. Multiplying by the original exponential gives e to the power of tangent of 2x times 2 times secant square of 2x. Applying the product rule, the derivative is 3x squared times e to the power of tangent of 2x plus x cubed times e to the power of tangent of 2x times 2 times secant square of 2x. Factoring out e to the power of tangent of 2x, so the final answer is e to the power of tangent of 2x times 2 times the quantity 3x squared plus 2x cubed times secant square of 2x. Next, question 2, part B. The function is y equals natural logarithm of sine x divided by the square root of x cubed plus 5. We rewrite it as natural logarithm of sine x times the quantity x cubed plus 5 to the power of negative 1/2. And use the product rule. First, differentiate natural logarithm of sine x. Using the chain rule, the derivative of cosine x divided by sine x or cotangent x. Next, differentiate x cubed plus 5 to the power of negative 1/2. Using the chain rule, the derivative is negative 3x squared divided by 2 times the quantity x cubed plus 5 to the power of 3/2. Applying the product rule, the derivative is cotangent x times the quantity x cubed plus 5 to the power of negative 1/2 minus natural logarithm of sine x times 3x squared divided by 2 times the quantity x cubed plus 5 to the power of 3/2. Combining over one denominator, the final derivative is 2 times cotangent x times the quantity x cubed plus 5 minus 3x squared times natural logarithm of sine x all divided by 2 times the quantity x cubed plus 5 to the power of 3/2.
Assalamualaikum and hello everyone. My name is Khairan Rakila and today I will explain how to find the derivative of y with respect to x using implicit differentiation. First, we are given an equation involving both x and y. The equation is exponential of x times y plus the natural logarithm of x plus y equals sine of x times y plus x cubed. We are asked to find the derivative of y with respect to x using implicit differentiation. Starting with the left hand side, for the exponential of x times y, we use the chain rule. The derivative is the exponential of x times y multiplied by the derivative of x times y. Using the product rule, the derivative of x times y is the x times the derivative of y with respect to x plus y. Next, we differentiate the natural logarithm of x plus y. the derivative of natural logarithm of x plus y is 1 over x plus y multiplied by the derivative of x plus y. The derivative of x plus y is 1 plus the derivative of y with respect to x. Now, we move to the right hand side. The derivative of sine of x times y is cosine of x times y multiplied by the derivative of x times y. Again, using the product rule, this becomes x times the derivative of y with respect to x plus y. The derivative of x cubed is 3x squared. After differentiating both sides, we expand all terms. We then group together all terms that contain the derivative of y with respect to x on one side, and all terms without it on the other side. Next, we factor out the derivative of y with respect to x from the terms where it appears. Finally, we divide both sides by the remaining expression to isolate the derivative of y with respect to x. Hence, the derivative of y with respect to x is obtained as a fraction where the numerator consists of y times cosine of x times y plus 3x squared minus y times the exponential of x times y plus 1 over x plus y, and the denominator consists of x times the exponential of x times y plus 1 over x plus y minus x times cosine of x times y.
Assalamualaikum and hello everyone. My name is Nur Arisha Azwa binti LB, and I will explain the question number 4. Use linear approximation to estimate the value of ln 1.02 minus 2 over 5 square root 1.02 correct to 3 decimal places. First thing first, from the question we know that the x is 1.02. Next, we need to find the x naught, which is the closest value of x. In this case, x naught is 1.00. We have to use formula delta x equal to x minus x naught, which is 1.02 minus 1.00 equal to 0.02. Next step, we have to put the equation in fx form, which is let fx equals to ln x minus 2 over 5 square root x. In this step, we have to differentiate the fx. In the end, we have ln x minus 2 times 2x exponent negative 1 over 5. For the next step, we need to find f prime x and differentiate it again from our fx answer. As you can see, we need to use product rule. So the formula is uv prime plus vu prime. Then the f prime x is brackets ln x negative 2 brackets negative 1 over 5 x exponent negative 6 over 5 plus 1 over x exponent negative 1 over 5. Next step, we need to calculate the f1.00. So use the equation from fx and substitute the 1.00 into x. It becomes ln 1.00 negative 2 over 5 square root 1.00, and then the final answer is negative 2. Same goes to f prime 1.00. We also need to use the equation from f prime x, and then the final answer is 7 over 5. For the last step, we have to use formula, which is fx approximates to fx naught plus f prime x naught times 2x minus x naught, and then since we already know the f 1.00 is negative 2, and then f prime 1.00 is 7 over 5, for the delta x is 0.02, so we need to calculate it, and then the final answer is negative 1.972.
In conclusion, differentiation is an important concept in calculus that is used to determine the rate of change of a quantity or the slope of a curve at any point. It helps us understand how one variable changes in relation to another, which is useful in mathematics, physics, and everyday situations such as motion and growth.